Dear all, welcome back to my cybersecurity deep dive appointment, where I zoom in technical security topics to cross-reference trends and forecasts. In this episode, we will walk through the evolution of industrial Internet of Things malware and attacks, with a focus on the manufacturing industry. Let's kick off. We need to focus on the big change in the actual industrial installation and design of sensors. Sensors were designed to be mechanical, with all the flows they could have, in terms of allowing only visibility on-site through their instruments. They were, by their own design, simpler devices. Nowadays, most installations have moved to the industrial Internet of Things, with the pros of telemetry towards the complexity of supply chain attacks, also at the firmware level. Now, let's consider the previous statements in the context of industrial network design. If we refer to the Purdue model, sensors are at layer 0. That level was always connected by bus connectivity and isolated by nature, while firmware updates and telemetry broadcasts are enlarging the attack surface at one of the most critical layers of the overall security architecture foundation. Another issue is that the industrial Internet of Things could become the lateral move layer in case of a compromise, being often in an industrial DMZ layer, if it does connect, at the same time, insecurely, to an inner layer 0. If we analyze the overall picture from a MITRE ICS framework perspective, checking the evolution of the more recent malware, avoiding, for example, Stuxnet origins would include sensor tampering. We can see how the attacking capabilities of MITRE were still at the sensor level, towards grabbing device telemetry, then moved with Triton on turning off safety systems and acting as network disruptor. When we analyze Indestroyer 2.0, we reached the top of the attacker capabilities, directly altering operational parameters, with a dynamic pipeline to deliver various attacks towards OT environments. If you look at security research, one of the main OT security research project is LogicLocker ransomware, designed as a proof of concept for the PLC stack, showing the weakness of modern OT infrastructures. Unfortunately, this white hat project inspired changes in the criminal malware deployment roadmap, and we see many changes in Triton and Indestroyer following the same changes in this project. Considering the most recent deployments of OT malware, even if there is no actual IoT integration in LogicLocker, I can forecast the layer 0 sensor issue to become a standard de facto attack vector, used to allow persistence, move laterally across all OT layers and be used as command and control, for example using an AI API logic, to define action, towards environment scan results. As you can see, the picture is complicated, and considering a documented increase in IoT malware attacks, this described scenario is just a reasonable assumption in a short term. So far, we analyzed together how the change in the type of sensor, from mechanical to IoT devices, in one of the most critical layers of the security architecture of the OT estate, makes it a perfect leverage for attacks, and how the malware evolution witnessed this shift towards considering IoT a significant attack vector for industrial manufacturing. Now, let's evaluate how the context around this topic is even more worrisome. Industry 4.0 is pushing for more industrial telemetry, and the advanced analytics, for example, in industrial quality control, is pushing towards a cloud transformation. Suppose we add the integration that industrial IoT will have with AI agents automation. In that case, the attack surface increase by the amount of API will enhance OT automation, such as GraphQL API, with all connected risks. A complex supply chain attack, especially in terms of software development integrity and continuous leverage of social engineering and dark hiring in programming space, for example, implanting a backdoor in firmware, plus an increase of standardized industrial solutions, that make each OT estate less unique and easy to be guessed in terms of design and solution. I can state without any doubt that the industrial IoT layer will be stressed. So far, the industrial IoT gateways are not properly integrating network segregation and security controls. Adding the segregation across IT and OTCM, missing most of the time integration due to a different nature, being OT more passive network sniffing than active scanning, like IT. We can guess how the industrial IoT is going to be weaker and less protected. Thanks for listening to this analysis on industrial IoT security, and I hope you did enjoy it. I do craft manually and create research for the security community to increase awareness and help new security professionals become confident in protecting complex environments. Follow me on YouTube. I do release free content on the sharing is caring principle, but your continuous support for the efforts is highly appreciated. Thanks, take care, and speak to you soon.